Akatsuki, also known as the Venus Climate Orbiter and Planet-C, is a Japanese space probe tasked to study the atmosphere of Venus. It was launched aboard an H-IIA 202 rocket on the 20th of May 2010, and failed to enter orbit around Venus on the 6th of December 2010. After the craft orbited the Sun for 5 years, engineers placed it into an alternative elliptical Venusian orbit on the 7th of December 2015 by firing its attitude control thrusters for 20 minutes. By using 5 different cameras, Akatsuki will study the stratification of the atmosphere, atmospheric dynamics, and cloud physics. Mission: Akatsuki is a Japanese space mission to the planet Venus. Planned observations include cloud and surface imaging from an orbit around the planet with an infrared camera, which are aimed at investigation of the complex Venusian meteorology. Other experiments are designed to confirm the presence of lightning and to determine whether volcanism occurs currently on Venus. In most planets, the atmosphere circulates much slower than the rotation speed of the planet. However, on Venus, while the planet rotates at 6 km per hour at the equator, the atmosphere spins around the planet at 300 km per hour. Akatsuki is Japan's first planetary exploration mission since the failed Mars orbiter Nozomi probe, which was launched in 1998. Akatsuki was originally intended to conduct scientific research for 2 or more years from an elliptical orbit around Venus ranging from 300 to 80,000 kilometers in altitude, but its alternate orbit, yet to be characterized, had to be highly elliptical. The budget for this mission is 14.6 billion yen for the satellite and 9.8 billion yen for the launch. Spacecraft design. The main bus is a 1.45 x 1.04 x 1.44 meters box with 2 solar arrays, each with an area of about 1.4 square meters. The solar arrays provide over 700 W of power in Venus orbit. The total mass of the spacecraft at launch was 517.6 kilograms. The mass of the science payload is 34 kilograms. Propulsion is provided by a 500 Newton bipropellant, hydrazine dinitrogen tetroxide orbital maneuvering engine and 12 monopropellant hydrazine reaction control thrusters, 8 with 23 N of thrust and 4 with 3 N. It is the first spacecraft to use a ceramic retrofire thruster. The total propellant mass at launch was 196.3 kilograms. Communication is via an 8 GHz, 20-watt X-band transponder using the 1.6 meters high-gain antenna. The high-gain antenna is flat to prevent heat from building up in it. Akatsuki also has a pair of medium-gain horn antennas mounted on turntables and 2 low-gain antennas for command uplink. The medium-gain horn antennas are used for housekeeping data downlink when the high-gain antenna is not facing Earth. Instruments. The scientific payload consists of 6 instruments. The 5 imaging cameras will explore Venus in wavelengths from ultraviolet to the mid-infrared. The lightning and aglo camera will look for lightning in the visible wavelengths of 552 to 777 nanometers. The ultraviolet imager will study the distribution of specific atmospheric gases such as sulfur dioxide in ultraviolet wavelengths. The long-wave infrared camera will study the structure of high-altitude clouds at a wavelength where they emit heat. The 1 micrometer camera will image heat radiation emitted from Venus's surface rocks and will help researchers to spot active volcanoes, if they exist. The 2 micrometers camera will detect heat radiation emitted from the lower reaches of the atmosphere. The ultra-stable oscillator for high-precision measurement of distance and communication. Public relations. A public relations campaign was held between October 2009 and January 2010 by the Planetary Society and JAXA, to allow individuals to send the name and a message aboard Akatsuki. Names and messages were printed in fine letters on an aluminium plate and placed aboard Akatsuki. 260,214 people submitted names and messages for the mission. Around 90 aluminium plates were created for the spacecraft, including 3 aluminium plates in which the images of the Vocaloid Hatsune Miku and her super-deformed figure Hatsune Miku were printed. Operations. Launch. Akatsuki left the Sagamihara campus on the 17th of March 2010, and arrived at the Tanegashima Space Center's Spacecraft Test and Assembly Building 2 on the 19th of March. On the 4th of May, Akatsuki was encapsulated inside the large payload fairing of the H-IIA rocket that launched the spacecraft, along with the Icarus solar sail, on a 6-month journey to Venus. On the 9th of May, the payload fairing was transported to the Tanegashima Space Center's Vehicle Assembly Building, where the fairing was mated to the H-IIA launch vehicle itself. The spacecraft was launched on the 20th of May 2010 at 21 hours 58 minutes and 22 seconds from the Tanegashima Space Center, after being delayed because of weather from its initial the 18th of May scheduled target. Orbit insertion failure. Akatsuki was planned to initiate orbit insertion operations by igniting the orbital maneuvering engine at 23 hours 49 minutes and 0 seconds on the 6th of December 2010 UTC. The burn was supposed to continue for 12 minutes, to an initial orbit of 180,000 to 200,000 kilometers apoapsis, 550 kilometers periapsis, 4 days orbital period around Venus. The orbit insertion maneuver was confirmed to have started on time, but after the expected blackout due to occultation by Venus, the communication with the probe did not recover as planned. The probe was found to be in safe hold mode, spin-stabilized state with 10 minutes per rotation. Due to the low communication speed through the low-gain antenna, it took a while to determine the state of the probe. JAXA stated on the 8th of December that the probe's orbital insertion maneuver had failed. At a press conference on the 10th of December, officials reported that Akatsuki's engines fired for less than 3 minutes, far less than what was required to enter into Venus orbit. Further research found that the likely reason for the probe malfunction was salt deposits jamming the valve between the helium pressurization tank and the fuel tank. As a result, engine combustion became oxidizer-rich, with resulting high combustion temperatures damaging the combustion chamber throat and nozzle. A similar vapor leakage problem destroyed the NASA Mars Observer probe in 1993. Recovery efforts. JAXA developed plans to attempt another orbital insertion burn when the probe returned to Venus in December 2015. This required placing the probe into hibernation or safe mode to prolong its life beyond the original 4.5-YEAR design. JAXA expressed some confidence in keeping the probe operational, pointing to reduced battery wear, since the probe was then orbiting the Sun instead of its intended Venusian orbit. Telemetry data from the original failure suggested that the throat of its main engine, the orbit maneuver engine, was still largely intact, and trial jet thrusts of the probes on board OME were performed twice, on 7 and the 14th of September 2011. However, the thrust was only about 40 newtons, which was 10% over expectations. Following these tests, it was determined that insufficient specific impulse would be available for orbital maneuvering by the OME. It was concluded that the remaining combustion chamber throat was completely destroyed by transient ignition of the engine. As a result, the selected strategy was to use 4 hydrazine attitude control thrusters, also called reaction control system, to drive the probe into orbit around Venus. Because the RCS thrusters do not need oxidizer, the remaining 65 kilograms of oxidizer was vented overboard in October 2011 to lighten the spacecraft. 3 peri-Venus orbital maneuvers were executed on the 1st of November 10 and the 21st of November 2011 using the RCS thrusters. A total delta V of 243.8 meters per second was imparted to the spacecraft. Because the RCS thrusters' specific impulse is low compared to the specific impulse of the OME, the previously planned insertion into low Venusian orbit became impossible. Instead, the new plan was to place the probe in a highly elliptical orbit with an apoapsis of 100,000 kilometers and a periapsis of a few thousand kilometers from Venus. Engineers planned for the alternate orbit to be prograde and lie in the orbital plane of Venus. The method and orbit were announced by JAXA in February 2015, with an orbit insertion date of the 7th of December 2015. The probe reached its most distant point from Venus on the 3rd of October 2013 and had been approaching the planet since then. Orbit insertion. After performing the last of a series of 4 trajectory correction maneuvers between the 17th of July and the 11th of September 2015, the probe was established on a rendezvous trajectory with Venus. The rendezvous occurred on the 7th of December 2015, when Akatsuki successfully entered Venus orbit after a 20-minute burn with 4 thrusters that were not rated for such a hefty propulsive maneuver. Instead of taking about 30 hours to complete an orbit around Venus, as was originally planned, Akatsuki will complete one orbit every 9 days after an adjustment in March 2016. After JAXA engineers measured and calculated its orbit following the December 7th operation, JAXA announced on December 9 that Akatsuki had successfully entered the intended elliptical orbit as far as 440,000 kilometers from Venus, and as close as 400 kilometers from Venus's surface with an orbital period of 13 days and 14 hours. Status: a follow-up thruster burn on the 26th of March 2016 lowered Akatsuki's peak altitude of its orbit to about 330,000 kilometers and shortened its orbital period from 13 to 9 days. The orbiter started its 2-year regular science operations in mid-May.